2.4, rates of change in tangent lines, worked out problems. So off we go. Find the average rate of change. Bless it out, you'll get 1. Your basic plug and chug. Yeah, there we go. Wish it was more exciting than that. It's not. All right. You can always graph this and see if that's what you get for average rate of change. For example, for cosine, from here to here, if we threw a line through it, it's a negative slope. From here to here, if we threw a line through it, slope of 0. Always good to be aware of those things. All right, this is some weird stuff. Boy, it took me a long time to make this graph, I might point out. This is a time graph for wrench falling. Ooh, look, units. All right, estimate slopes for Q1, for PQ1, for PQ2, for PQ3, for PQ4. What they're trying to do is show you that as we go here, 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 we get closer and closer to the actual tangent line. Yeah, whatever. Yeah. I got nothing else to add to that. So here's our points. 10 gets us out 80. Q1. And no, I'm not 100% sure I'm getting these exactly right, but they'll have to do. Q2, Q3. You might get slightly different numbers. There's nothing wrong with that. So then the slope of PQ1 And I'm not going, I will go through all the data. Always so tempting to just be lazy about it. By the way, this took me a long time the first time I did it. But making it look easy, I do apologize. Notice it's almost like we're taking a limit as we get closer and closer to P. The secant becomes a tangent. We're desperately trying to get you to understand that concept. It sure looks like the instantaneous rate of change, also known as the instantaneous speed at P is approximately 16 meters per second. Notice we were given units, so we give units back. Meters, seconds. At the indicated point, find the slope of the curve, equation of tangent line, yada, yada, yada. Do it the long way, and then get around to doing it the shortcut way. Limit h approaches 0. I could write all this out and do all the distribution, but I've done that before. We'll get 2x minus 4 at x equals 1, m equals negative 2. We also need the point, so we write that in here. 1 comma 1 squared minus 4 is negative 3. Yep. Y equals, now I'm just throwing my other point over, it's negative 3. So y minus negative 3 is plus 3, so negative 3 goes on that side. Negative 2, x minus 1, minus 3. And the normal line, one half x minus 1 minus 3. I've just done about 3 or 4 of the math problems you'll see on the AP exam next spring. What's our point? Plug in 0, get out negative 1. Limit h approaches 0. Over h equals 2x minus 3 at x equals 0, m equals negative 3. Tangent line, y equals negative 3x, because it's x minus 0, and I'm not writing that, minus 1. Y equals 1/3 x minus 1. Again, at least 2 to 4 problems on your AP exam next spring, and a faster way to do this. Remember, it's just 2x minus 3. Oh, look at that, 2x minus 3, and the negative 1 vanishes. 2x minus 4. Find the slope of the curve at the indicated point. Now, whenever you look at something and go, I don't know how to do that, graph it. This is a trick you will see a lot. I don't know what to do here. Well, we better graph it. At x equals 2, slope is 1, slope is negative 1. So that's it. So, well, I had to do all this algebra. Yeah, sometimes you just got to graph it and be smart. X minus 2 should go left, but x equals 1. No. And x equals 1, m equals negative 1. Cool. Determine the curve as tangent. If it does, if it's not, explain why not. So we basically got a bunch of piecewise here. Open. X equals 0. Does it have a tangent? Well, let's see if we can find a limit. Over here, it's real simple. The slope is negative 1. And the limit as h approaches 0. And then we know it's 0, and that's where the function matters. So x plus h squared minus x plus h minus x squared minus x. Why would I write h equals 0? Definitely getting punchy doing all this math. It's actually good advice. I would probably do this in 2 or 3 chunks, not try and do it all at once. Blast it out. We already know we get 2x minus 1 at x equals 0. We get slope equals negative 1. So yeah, since the tangent over here is negative 1, and over here is negative 1, because it's a limit. Limit's got to be the same coming from both sides. Yeah, all that nonsense. That's why we did limit rules. So yeah. Wow, that was a lot of work. Sine of x, 2 sine of x, something like that. Add 3 pi over 4. Well, there's no tangent line, obviously. Can't find a limit because the function has jump discontinuity. We're doing math. Yeehaw. Slope of the curve at x equals a. And describe what happens. Now, I've gotten lazy because I'm tired of doing this. So I'm going to say this is 2x the negative first. Therefore, the slope is negative out front, -2, subtract 1, x negative second, m, and that is -2 over a squared. When I plug in a, m at a. All right, slope's always negative. And we really got to write this right. Slope of tangent line is always negative. And then I would say the closer we get to 0, we can't plug in 0. This number becomes freakishly small, which means the slope becomes freakishly big. And bigger just means larger number, not more positive. And when we are further from 0, smaller slopes. If you didn't write any of this down, yeah, that's fine. Don't worry about it at all. Okay. So m equals -2x. M at a equals -2 times a. So, I don't know. Let's just write some crap down. Slope of the tangent line at 0 is 0. And then it becomes steeper as you get further from 0. I'm making this up as I go along. Don't kid yourself. From 0. Weird stuff. All right. IROC, instantaneous rate of change. By the way, I was lazy up there on purpose. You could do it the long way. You can get the same answer. We've shown it several times. Now I'm going to go back and do it the long way. Just mixing it back and forth to get comfortable with it. That's all there is to it. So here we go with the limit. As h approaches 0, 3 t plus h squared plus 2 t plus h minus 3t squared plus 2t all over h equals 6t plus 2. This seems like it's written wrong. It's just saying the function's in feet and the time is in seconds. All right, it says that t equals 3. At t equals 3, we would write it as, I guess we'll go with IROC. 6 and 3 is 18, plus 2 is 20 feet per second. Notice they gave us units, so we give them back. Limit three t squared at t equals 2 equals 12 feet per second. All right, at t seconds after liftoff, the height of a rocket is 3t squared feet. So back we go again. Limit as h approaches 0 of 3t plus h squared minus 3t squared over h. I'll do this one long way just because I'm feeling nostalgic. 3t squared plus 2th plus h squared minus 3t squared for h equals, plug in 0, 2t. And t equals 10 seconds. The velocity, that's actually kind of a big jump going from IROC to velocity, equals 20 feet per second. Forgot my 3 here. Oh, that's upsetting. 3 times 2 is 6t. It would be 60. Well, mistakes happen. At what point is tangent horizontal? So when does m equals 0? Limit h approaches 0. 3 minus 4 times x plus h minus x plus h squared minus 3 minus 4x minus x squared over h equals negative 4 minus 2x. 0 equals negative 4 minus 2x. 2x equals negative 4. X equals, doesn't give me units, negative 2. At what point is the tangent to horizontal? Now, careful, this is not specific and the AP test will be. Well, I have to put it in. Point, negative 2 comma 4, 8 minus 4, 3 is 7. Yeah, pay close attention. All right, last of the baby work. Next unit, we get serious. Good luck and happy mathing.